All right, this this lesson, I hate to even start off a lesson by saying this, but it kind of it troubles students from time to time because we're going to be dealing with fractions on this lesson. Okay? Yeah, I know the feeling. Okay. But what we're going to do, so we don't have to call them fractions, we call it, I don't know if this makes it any better or not, we call them rational expressions. All right, look at this word in the word rational. Ratio. Okay, basically in your normal everyday language, what's basically a ratio? What do you think?
Comparison or a fraction.
Okay, it is a comparison, right, and it's a fraction. Okay, that's what I'm looking for. You're absolutely right, though. A ratio is a comparison between two things, and it's a we can write it as a fraction. Okay, so basically, when you see the word rational, we're talking about fractions. Okay, we're talking about one thing over another, or one thing compared to something else. All right, so we're going to do some things with fractions. We're going to learn how to work with this a little bit, and let's see what I want to do here. For instance, if I said this, if I said, let's start really easy. 3 plus 2 over 5 plus 2. If I asked you to simplify that fraction, what would you do? Jared? Okay, yeah, add the top one, you get what? 5. And add the bottom one, you get? 7. Okay, very good. All right, pretty easy, right? So fractions aren't so scary so far, are they? Pretty simple. You know what a lot of people might do with this, though? Yeah, a lot of people look at this and say, oh, I got a 2 on the top, I got a 2 on the bottom, they cancel each other out. Okay, you've heard that for years, haven't you? Stuff that cancels each other out.
3 plus 3 over 5 equals 5.
Okay, let's try that. Let's just try and see if it works, if you can cancel them out. So the 2 cancels out with the 2, or does it? I'm going to put a big question mark, okay? Does the 2 cancel out with the 2? All right, and the way that I'm asking this question, you probably figure it's not going to work, right? So what would that give you? That would give you 3/5. Well, that means 3/5 and 5/7 must be the same exact thing. Are they the same thing? No, I don't think so either. So let's just try it and see what it is. What's 5/7? 5 divided by 7, and that's 0.714. Okay, 0.714. And what's 3/5? You can do that in your head. What's 3/5 in your head?
0.6.
That's 0.6, isn't it? 6/10, because 3, if you, right, 5 times 2 is 10, 3 times 2 is 6, 6/10, so it's 0.6. Are they the same thing?
No.
Obviously, they're not the same thing. So can we just cancel out the 2's if you see a 2 on the top and a 2 on the bottom? No, you can't. What if you had this, though? What if you had 3 times 2 over 5 times 2?
See?
Let's do what we did before. Jared said we add them up, right? Add up the top, add up the bottom. Well, let's do the same thing here, except we're not adding. What are we doing here? We're multiplying, so let's do that. 3 times 2 is 6 over 5 times 2 is 10. That's 6/10, isn't it? Well, that looks familiar. So what do you think I could have done right at the beginning instead of actually multiplied them through like this? I could have canceled them out and got that 3/5, because 3/5 is the same as 6/10, isn't it? So look, why can I cancel them here and I can't? See, no. All right? You cannot cancel the 2's out right here. Right here, yes. We can cancel the 2's here.
That one's multiplication.
Exactly. This one right here is multiplication. Do you see that? This one right here is addition. Because really, if I say cancel out, and we use the word cancel out a lot, but and I'll use it. Okay, I got nothing against it. I know some teachers that will never say cancel out. I've had them in college. But I'm okay if you say cancel out as long as you know why you're canceling them out. Because look, this 2 is being added to something, and this 2 is being added to something. But what's in between the 2 and the 2 right here? It's division, isn't it? Let me ask you this. When we say we cancel something out, usually we're doing the opposite of something. All right? Is addition and division opposites of each other? No. Let's go down to here, though. What's this 2 doing to 3? Multiplying. What's this 2 doing to the 5? Multiplying. What is going on between the top and the bottom, though? Division. Is multiplication and division opposite of each other? They are, okay? If they're opposite each other, then you can cancel stuff out. Do you see the reason why? All right, so yeah, you're allowed to cancel out. They actually divide out. They divide out to be a what? 2 divided by 2 is a 1. So really, it's just 3/5 times 1, isn't it? All right, which is the same thing as 6/10. Is 3/5 the same thing as 6/10? Absolutely. Wasn't it easier just canceling the 2's out, and then you're already left with your simplified fraction? Because if you multiplied them together, you get 6/10. Then what would you have to do with this? Yeah, reduce it. 2 goes into this 3 times, 2 goes into this, what? 5 times. We already took the 2 into both of them right here, didn't we? And then you still get 3/5. You see it? I know I'm being a little bit technical here, but I want you to understand why things cancel out and why they don't cancel out. All right? If it's being added to something and it's on the top and bottom, they will not cancel out. Now watch this. If I had like -3, how would I cancel out if you wanted to say a -3 by adding... Oops, what did I put 2 for? I don't know why. Let's put a 3. Come on, little circle. There we go. Now, they kind of cancel each other out, don't they? All right? -3 plus 3. You know, people say that. But what do they do, really? They add up to 0. Remember, if we had something like this. Watch if I had... I'll just make this real easy. Watch. We subtract 3. We subtract 3. Agreed? They're the opposite of each other. What do we always say in Algebra 1 when we do this? They do what? They cancel out. But really, what are they doing? They're adding up to be what? 0. All right? So that's what I want you to understand. What if you had this? What if you had 3x equals 12? What do we do here? We don't subtract a 3, do we? We do the opposite. What's the opposite? Dividing. Remember this? Okay, this is all coming back to you, right? So you divide by 3. So the 3's what? Cancel out. How do they cancel out here? They cancel out because they're dividing. 3 is being multiplied by x. How do you get rid of it? You divide it. That's why they cancel out. We say cancel, but two completely different things are happening here and here, aren't they? This one right here, you're subtracting a 3. This right here, you're dividing by 3. You still get rid of that 3, but you get rid of it by completely different reasons. Make sense? All right. I can see it in your eyes. This is as dry as sandpaper, I guess. All right, but I'm doing this for a reason. What if you had this? And I told you to simplify this. Cancel out the x's, right? 6 over 2. 6 over 2 is 3. That's my answer. What's wrong with that line of thought there? Ashley, tell me. What's wrong with that line of thought that I could cancel out the x's here? Because it's being added, exactly right. Because it's being added, okay? They're going to get more complicated than this. Okay, I'm starting off real basic, okay? Because you're going to see it a little bit later where it's going to look like you want to cancel stuff out, but I'm going to refer you back to this whole little talk right here. All right, you cannot cancel this out. So you can't say 2 goes into 6 either, can you? I've seen that happen. Believe me, I've seen students do a lot of crazy things. And that's one thing that people try to do. You can't do that. So what can you do with this? Nothing. It's already simplified. There's nothing that you can do to that to simplify it. Everybody with me on that? What if you had this? What if I asked you to simplify this? Can you cancel stuff out here? But I thought if something was being added, that 4 is being added to the x, I thought we couldn't cancel it out if it's being added.
It's also being multiplied.
Right. You got to look at this as one thing, okay? One term thing, okay? But yeah, look at it as one thing. Look at it as one complete term right here, because this one complete term is being multiplied by this one whole parentheses right here. Do you see that? This parentheses is being multiplied by this. So even though that there's a plus in here, what is this whole parentheses doing? It's multiplying. What is this whole parentheses doing to this? It's multiplying. Well, you got one over top of the other, right? One being divided by the other. So do they cancel out here? Yes, they do. They divide out. So this divided by this is a 1. So yes, they do cancel out because I have to look at this whole entire parentheses as one unit, as one term. Okay? And they do cancel each other out. They divide each other out. We use cancel all the time, but they divide each other out. So what are you left with? X plus 6 over x plus 2. We already said that we can't simplify that, and so that would be our simplified answer right there. We okay with that? All right. Now, let's really get into some stuff here. What if we had this? Remember what I said before this that first half of that chapter was over? I said we're going to, don't forget about it because we're going to use this stuff all throughout the year. It's just one. I mean, this is only one lesson later, but we're going to use a lot of the stuff that we've learned earlier to do different problems. Okay, this is going to say to simplify, or it says express it in lowest terms. This book says it, but a lot of times you'll see books that just say simplify or express this. What does it say? Write each rational expression in lowest terms, which means just simplify it. All right, cancel stuff out if you can cancel out. You know what a lot of people might do? A lot of people see this p squared and this p squared and cancel them out.
No,
You can't do that.
work
But
that
then
way.
I've had people say this, and it's a legitimate question. Yeah, but this p squared is being multiplied by 2. You said if it's being multiplied, I could cancel it out. But you have to look at the whole entire term. Look at the whole entire term that it's a part of. Okay? What's that whole entire term doing to these other terms? Come on, talk to me. What's this whole entire term doing to
Being
this 7p?
added.
It's being added, isn't it? Okay? So I have to look at this whole entire term as one thing, as one unit. All right? So I can't just say, oh, that p squared is being multiplied by 2, so that cancels with this. No, you got to look at this whole thing. Look at this whole thing right here. What is that being? What's going on down here? It's being added, isn't it? So can I cancel out the p squareds? No. Can I cancel out the p's right here? No. Can I take 2 into 20 right here? No, I can't because it's all being added. So I'm kind of stuck. What in the world do I do? Well, what do these kind of look like, this thing right here? What does it look like I possibly could do that we had a test on just the other day? Okay, I could factor it out. Exactly right. Because what I want to do is I want to get something times something else. Notice this stuff right here. This was kind of factored, wasn't it? X plus 6, x plus 4. They were things that are being multiplied together. If I can get things that are multiplied together, then I can cancel stuff out. If I have a fraction, right? If I have a division going on here. Does that make sense? Let's get rid of all that. Okay, so let's see if that factors. My guess is they've probably rigged this, so it probably will factor. All right, so let's try it. My signs, one's going to be positive, one's going to be negative. All right, so they have to multiply. Let's see, they have to multiply to be 2p. So let's go 2p and p. To multiply to be 4. So let's just try 2 and 2, see if that works. What do we get? That's not going to work, is it? The outside is negative 4p. The inside is positive 2p. That doesn't give me 7. So let's try. Tell you what, I don't think 2 and 2 is a good choice. Let's try 4 and 1. Let's see if that works. So let's try the outside. The outside is negative 2. The inside is positive 4. That still doesn't work, does it? Let's try switching the signs around. Let's see if that works. Let's try that and that. That's positive 2, negative 4. Now, that only changed the sign. Well, let's do this. Let's go back to what our signs were before. See, when I used to teach this stuff, I get real lucky and get it the first time. Now I got to try it a few times, don't I? That's good, though, because it's good. Let's switch the 4 and the 1 around. So let's stick the 1 here and the 4 here. Okay? Ah, there we go. Look at this. We're getting close, though, aren't we? 2p and negative 4, that's negative 8, plus 1, that's negative 7. Well, that's not negative 7, so what do you think I need to do now? Yeah, just change the sign. Right. So change that and change that. That's positive 8 minus 1. Yep, there it is. It's factored. Good deal. Took us a minute or two, but we got it. What about the bottom? How do we factor that? It's not regular trinomial factoring, is it?
Difference to.
No, it's not a difference
No.
of anything because it's a plus. And the only plus we have is a. Is it a perfect square? Is that what you're saying? Is it a perfect square? Nah, because I can't take the square root of 20 or p or 5. It's not a perfect square. What do we always look for? The very first thing when we factor stuff, we always, one of the first things that we learned, greatest common factor. Does it have a greatest common factor? It does. So 5 and 20, which one?
5.
5. P squared and p? P. So you factor out of 5p. What's left over?
1.
So it's this divided by 5p, which is
1p.
1p,
plus
right? Plus. And then this divided by 5p is 4. There we go. So we factor the bottom. Everybody see that? Now, how does that help us? Yeah, look at this. This p plus 4 is in parentheses, is being multiplied, isn't it? This p plus 4 is in parentheses, it's being multiplied. So guess what I can do with the p plus 4? Cancel them out. They divide out, right? That's probably a little bit better way to say it. Again, I don't really mind if you say cancel out, but I'll probably say divides out to be a 1, just so that it sticks in your head that that's why it cancels out, okay? Now, what can we do here? 2p minus 1 on the top. What's on the bottom? 5p. Do the p's cancel out right here? No, because this right here is part of a subtraction or an addition problem, right? Did you realize every single subtraction problem is an addition problem? So when I say addition, that even goes for subtraction, because subtraction is just adding the opposite. So really, every subtraction problem is an addition problem. So yeah, there you go. And now it's simplified. Now it's in its lowest terms. You can't do anything else with that. And then you're finished. That's it. That's the kind of stuff that they're going to ask you to do. All right? Let's try another one. Let's go 6 minus 3k over k squared minus 4. This one has a little trick to it. But at first, it's pretty straightforward. What do you think we're going to do here? Does anything cancel out? Do the k's cancel out? No. Does 2 go into 4 and 6? Not in this situation, because the 6 is being, something's being added to it, something's being added to the 4. So you can't cancel anything out the way it's sitting right now. So you got to do some stuff. What do you think you can do to the top? Do you recognize anything on the top? Greatest common factor. Yeah, you factor it out. Greatest common factor. So what's in common with both of these?
3.
A 3. So you factor that out. That's a 2 minus k. All right? Look at the bottom. This is a difference, isn't it? It is a minus. And I do have something that's being squared here. And I do have something that's being squared here. So this is a difference of what? 2 squares. So how do we write difference of 2 squares? I had some of you guys on the test taking a difference of 2 squares and writing it as a perfect square. Right? No. Difference of 2 squares, 2 parentheses, positive in one, negative in the other. So it's k and 2, k and 2. Now does anything cancel out? Yeah, I like that response. She said, yeah, oh, well, that's what I want you to see. Because look, it kind of looks like this and this would cancel out, doesn't it? Because I got a k and a 2 and I got a minus. But is this top and this bottom exactly the same? No, it's not. What in the world to do? Don't know. I kind of do, actually, but what do you think? Any ideas? Flip them? There's really no rule to flip from one, like from the top to the bottom, because we don't have exponents.
Can you say turn both of those negative and switch the numbers around?
Okay, good idea. I like that. Watch this. Let me backtrack a little bit here. If you had a negative divided by a negative, what is a negative over a negative? It's positive, right? Okay, positive 1. Would you agree? Now watch what I'm going to do here. Watch very carefully. I'll do this in a different color. So what I'm going to do is I'm going to multiply the top by a negative. So I'm going to multiply that by a negative. Now watch. I want to backtrack a little bit here too. If I had like 3 times 5 over, I don't know, 2 times 4. Okay? Now watch this. If I multiply the top by a negative, does it matter which one's actually being negative? Because if I put a negative on the top, negative 3 times 5 is negative 15, isn't it? Or I could have said, what? 3 times negative 5. Would you agree? So it doesn't really matter which one's going to be negative. Just putting a negative in one of them is going to make that whole top a negative. Would you agree? So I could have made that negative, and I could have made this negative. Did I really change the value of my original problem here? I didn't, because a negative divided by negative is a positive. I didn't really change the value. So watch what I'm going to do. I'm going to put a negative on the top and a negative on the bottom. Now, it doesn't really matter which one we apply the negative to. But the only reason that we're doing this is to apply the negative to this right here. Does that make any sense? I'll show you. You'll see how it works out. So watch. Even though I put the negative out in front, what I'm going to do is I'm going to apply that negative to this parentheses. So what happens if I apply a negative to this parentheses? This becomes a negative 2, and this becomes a positive k. Everybody see that? It becomes a negative 2, and it becomes a plus k, because I'm distributing that negative through this parentheses. Then I can flip it around. Do you see this? Then I can flip it around, and what do I get? I get k minus 2. Let me finish this one up real quick. Then what could I do here? I could just take this through this second one. Watch. Negative k minus 2 right? I'm applying that to this, and then what's this? That still stays the same. Look what I can do now. Now the k minus 2 cancels out. What's my answer? It's 3 over negative k minus 2. I hope you wrote that down. We'll try to go over another one like that tomorrow. And we didn't quite get to where I wanted to get today, so I'll just give you a worksheet tomorrow to work on, and no homework tonight.